Can you hear me now?
Yes, but very low. Thankfully, most
Yeah,
of us
yeah,
will have volume that we can turn up, but you're a little low.
yeah. Thank you.
Okay. Okay. Excuse me. We're going to get started. I'm Lou Berger. I'm here with Janos Farkas, and our secretary Ethan said he was going to try to make it, although it is really early on the west coast of the U.S., but we do expect to see him. Thank you all for joining us at this interim. It is a formal IETF meeting, so our note well applies. I think everyone on the list here is pretty familiar with it, or else you wouldn't have made it into the interim. If you're not, just go to the note well. Please do try to practice good mic control. Make sure you're muted. We may mute you if you're not supposed to be talking. We also are going to use the queue to manage the discussion. The biggest item here is that please join us in the collaborative note-taking. I'll drop in the chat in just a minute a link to it, or Janos may do that. But please join us to make sure that we capture discussion. All the material is online. From a working group status, we've had a recent RFC published. Thank you all to those who worked on it. It was quite a bit of work. And we're close on a couple of other documents. We do have one recent adoption. It's helping drive the requirements for the discussion today. We did ask to rename from, in naming the sort of file name, we removed large scale and put in scaling. Some of the discussion during the adoption and before the adoption pointed out that a number of the requirements are just about building, scaling up DETNet. And rather than argue more about what is large scale and what is not, we're going to just use the term scaling. We do expect that to also propagate down to the title of the draft at some point. We have one liaison when there's a draft response that has been discussed on the list. There's been very little discussion, but that discussion did result in a change. In reading over the text, and I proposed the most recent change, I think it addresses both my comment and the comment of the other comment that was raised. We do ask that everyone take a look at the response and see if you have any additional comments. Without any comments, we expect to send this on the 16th. We'll actually make sure to say the same thing on the list. We have a pretty packed agenda. We are going to stick to the 2 hours. I'm going to keep going. So what are we doing? Excuse me. So why are we here, and what's the focus of the discussion? Well, we do have the enhanced DETNet data plane requirements document. That's what came out from the, that's what's in our chartered milestone. And, the scaling document we think fits that bill. On this session, we're going to really focus in on addressing queuing related requirements that are in that document. That document has lots of different things in it, but we're really just going to focus on one aspect of it, queuing, and any type of changes, on-wire changes that are necessary to support the queuing. We've had a couple of proposals on that, and we expect that to be the scope of this discussion. There are a lot of good individual drafts. We need to choose how many proceed. Are they combined? Are they maintained separately? Are some things of more interest, some are less? That's the normal working group processing. So we're going to do that normal processing, but also to help move things along, we expect to form a design team early next year. The charter has not been written yet. We expect this meeting to help inform an offline charter proposal that we'll be working. And once that we have a proposed charter, that will be sent to the list as well as a call for participants. We'll open it at that time. And again, this will be in the beginning of the next year. Thankfully, David Black, who has been acting as TSV advisor for the group for a long time, has agreed to act as design team lead. We think that's super appropriate because his working group has done much of the queuing work within the IETF. So we're really appreciative and lucky to have him. And with that, we are, I think, ready to move to the next presentation. So first up is Peng, if you want to join. And we're going to hand off queue control, slide control to you and see how that works. If it doesn't, we can pull it back. So Peng, you should be able to click next on the bottom of your, underneath the slides, you should be able to control them and control the advancing.
Yeah, I see it. Yeah.
All right, great.
So let me try. Yeah.
Perfect. Thank you so much. And if we don't have any questions on that first slot, we'll hand off to Peng. Okay, please proceed. Thank you.
Okay. Thank you. Tony from China Mobile, and it's a requirement of large-scale deterministic network. And for the name, maybe the scaling is a better choice. And we can see more comments from the co-authors because before that we don't really know the change of it. So my personally view is that it is acceptable. Yeah. So first, thanks for all of the people who review and support this draft. It was adopted and got so many good comments. The latest version was submitted with only the date and the file name changed, and the co-authors has been addressing the outstanding comments. So this presentation is to look through the motivation, structure, and the comments from such as Balas, Kiran, and Duv. The motivations aiming at the large scale, and in fact, we have changed in it to address heterogeneous characteristic with long hops, large per hop time variation, great number of flows, and multiple domains without the same source. And this document describes the technical requirements and the data plan requirement. Yeah, so this document has absorbed some requirements of Shom's large-scale enhancement, but this draft, the draft of Shom also updated into the next version, so some content of it is changed, and she also proposed some new points. We are also working on this on this work. Yeah. So let's have a recap of the key attributes of the large-scale DETnet. We define the large-scale DETnet network as a network that requires DETnet solutions for typical one or more of the following key attributes, including the clock synchronization or no clock synchronization in different domains, the combination of short and long-distance hops of the end-to-end path, and the various transmission rate, the large number of flows with different levels crossing the multi-domains, and more common scenarios of the topology change and the failures of link, and the mechanisms used to ensure the bounded latency. Maybe multiple or have different configuration of parameters in multi-domains. So we see that such domains are normally with a single administrative control network or multiple cooperating administrative network within a closed group of administrative control. And the overall technical requirements are close closely aligned with the key attributes. It is the latest submitted version, including to support the time asynchrony, large single hop propagation latency, higher link speed, massive traffic flows, failures of links and or nodes, and topology changes, and the enhancement of queuing mechanisms related to the configuration of multiple queuing mechanisms and the switch over crossing multi-domain. And following Bala's comments, we add a new requirement, so we can find them in the next slide maybe. Here are the data plan enhancement requirement to support the aggregated flow identification information used by functions, ensuring the deterministic latency, redundant related files, explicit path selection. Some of them is to show the requirement for the IPv6 to support the enhancement of the functions. And here's the summary of the outstanding comments. First one, adding the explicit requirement regarding flow fluctuation, and second is to some scenarios attributes are referred to the heterogeneity and not necessarily the skill itself. And it is better to discuss how current DETNET solution doesn't support large-scale scenarios and whether this is still in single domain or multiple domains. And clarify using CQF is not limited to 2 queues and it refers to the article in section 3.2. And some phrases that are marketing and that's not appropriate for the RFC publication. And consider at the time of publication when stating current numbers as they are likely to be outdated at some point, and correct the mirror errors in section 6. And now most of them has been addressed in a proposed new version of the draft, but it has not been posted to the mailing list, most because of the third one, because there are some text in each requirement subsection to see what caused by the large-scale DETNET and the single or multi-domain issues. However, the authors think about maybe some paragraphs to brief to see before the requirement section will help people to understand more about it. So we haven't decided this one, and once we address this, we will send the new proposed version to the mailing list. And to address the comment from adding explicit requirements regarding flow fluctuation, we propose to add a new requirement after requirement 4, accommodates the flow fluctuation in aggregation. Because more kind of traffic flows will cause more dynamic joining or leaving of the flows, which will further cause more flow fluctuation as well as more unpredictability of the DETNET flows. For instance, there will be more aggregation nodes which receives flows from more upstream nodes, which adds undeterministic delay of the packet treatment. Once one of the nodes makes a minor error of the packet treatment, it will has a bigger effect of the downstream nodes. Moreover, considering the node and link failure are more common in large-scale network, which requires dynamically traffic steering in another alternate path. It will also easily cause the flow fluctuation. And besides, it is almost impossible to identify the individual IP flows at the DETNET plan because of the large overhead and the resource reservation for a massive number of flows. So the Weight cards and value ranges used in the identification may have to change in order to ensure the aggregated flow has deterministic characteristics. And it is a proposed change of the requirement. And for the others comments to be addressed, we write them in the new version of the um, of the of the draft. So the next step, the proposed updated version will be sent to the mailing list, and I hope to get more comments and find together of it. So thanks, and any comments?
Please go ahead.
Okay.
David, please.
Sure. One small comment. In adding the new requirement on accommodate flow fluctuation, please distinguish the concept of toleration, where the mechanisms continue to work in the face of flow fluctuation, from recovery or restore, where the mechanisms are expected to undo the damage that has been done by fluctuation, restoring some sort of correct scheduling of packets.
Yeah, thank you. In fact, we just got a comment with a few words, and we will really work more about the flow fluctuation of it. Yeah.
Thank you.
Quan?
Go on, please go ahead.
Quan, please go ahead.
Submitted. Hello, do can you hear me?
Yes, we can hear you. Go on, please.
Okay, thank you. As Peng mentioned, the gap analysis of data plane was submitted. Hope that will help to make a clarification for the scaling networks and to display why the current data should be enhanced. So we could continue to discuss it offline to see which can be added in requirements draft. Thank you.
Yes, in fact, I replied to in the middle list, and we also want to hear more comments from the WG.
Greg?
Oh, yes, thank you. I wonder, do you see that it's possible to quantify what can be seen as a large latency? So one of the requirements, I believe, refers to tolerate large latency.
So you mean tolerates latency? For example, how large the latency can be tolerated? Do you mean that?
I think that probably it might be beneficial at least to explore if some bounds can be set to the requirements and to latency that can be tolerated by queuing. Because I believe that certain applications, they do have some requirements, and it's probably not practical to have to try to solve the problem for unbounded latency.
Well,
Again,
Do you have anything you want to add? When you're done responding, just ask David to go. Peng. So I think the request is just to, in the document, describe quantify what you mean by large latency, I would suggest think about it in terms of round trip time.
Right.
Yeah.
Or at
Okay.
least think of some bounds. Thank you.
Well,
David?
thank you.
And I was going to briefly add jitter to Greg's comment, as unbounded jitter is even more difficult than unbounded latency. I think this falls into the new requirement area about accommodating flow fluctuation.
Thanks,
Yes,
David.
we will consider that.
Torlis?
Would simple examples in terms of, this industrial wants to have jitter and latency below, I don't know, 1 millisecond, and wide area applications, I don't know, 8 millisecond or so. Improve by example first and then see how further on, because otherwise it's not quite clear what we would want to write.
Torlis, I think I heard the first comment, and I'm going to invite Greg to come back if he wants. But what I heard from Greg was he was talking about link latency. What I think you just said was application latency.
Okay.
So I might have misunderstood. I might have misunderstood Greg, and you can rejoin the queue if you'd like. But I heard a link. Greg?
Yes. Thank you. No, I was not about application. It was about their propagation. So the communication service.
So the distance also, what a distance. Okay.
Suggested then it could be looked together, latency and jitter.
Thanks.
Torlis, are you still in queue?
Nope.
Okay, great. Okay, I think we've reached the end of the queue, so we're going to move to the next. I believe it's Shusong. And you two should have slide control.
Hi, can you hear me well?
Please proceed.
We hear you.
Can you? Yeah,
Yes,
great.
we hear you.
Yeah,
Sorry,
so
I muted that it's a little slow going to mute on mute. And so
it's okay, it's okay. This is Xuesong, and I will give some introduction about our work on enhanced DETNET data plan requirement. This page is for some background about this work. In IETF-114 and YY5, we collect some suggestion by working group to split the document of DETNET enhanced data plan into 2 independent documents because the contents contain 2 parts. The first one is enhanced DETNET data plan requirement, and the second one is solution. So I just also see some comments in the chat box to ask whether these are the same topic. Actually, they are 2 separate topics in this call meeting because we are trying to separate these the documents into 2 parts, and my presentation is for the first part. First, I'm trying to provide a rough understanding of what is enhanced DETNET from my perspective. It's just give some thoughts. In DETNET data plan framework, forwarding sublayer is supposed to provide resource allocation and explicit routes. And before recharter, it is supposed to reuse the existing IETF and IEEE mechanisms to provide bounded latency and zero congestion loss in forwarding sublayer. There is a good summary in RFC 9320, which has just been published. In the document, it gives a timing model to compute end-to-end latency and bound different, and the bounds
of different queuing mechanisms. There are a lot of common queuing mechanisms that have been discussed in the document, including frame preemption, time-aware shaper, credit-based shaper, cyclic queuing, and forwarding, which are well defined in IEEE work. And after the working group has discussed about the recharter, and we are raising a new concept of enhanced DETnet. In my understanding, enhanced DETnet will define new layer 3 mechanisms for resource allocation, for bounded latency and zero congestion loss in order to satisfy new requirements. For example, the requirements has already been discussed by Peng in previous presentation, and which will give some modification or update or new mechanisms based on the existing work. So if we are on the same page about what is enhanced DETnet, maybe we are ready to discuss what is the requirement of enhanced DETnet data plan. As defined in RFC 9323, mechanisms are requested to provide bounded latency and zero congestion loss. The first one is resource allocation, which is supposed to configure and allocate network resource for the DETnet flows exclusively. And this part, I think, is supposed to be covered in the DETnet controller data plan. And also the encapsulation to identify the resources to be used by a given DETnet packet in the data plan. And which is also very important is to provide queuing, shaping, and scheduling mechanisms, which is the detailed behavior of allocation resources. It determines the transmission queue selection and the hardware in the device. Considering that as I have mentioned, the resource allocation is for the controller plan part, and the queuing mechanisms will be a lot of different variations and a lot of possibilities for different use cases and scenarios. So in this document, we will pay more attention to encapsulation, to answer the question what type of metadata will be requested for enhance the DETnet data plan. Basically, we give three kind of cases. The first case is that no new metadata is requested because there in our previous work, DETnet flow ID has already been defined, and that could be used by both forwarding sublayer and service sublayer. So it can also be reused if the enhanced DETnet mechanisms is flow-based. Also, some existing encapsulation in IETF could be reused, for example, DSCP. So in that case, we need no more new metadata. And there are also two other cases. The first one is we can explore metadata for enhanced DETnet that could use by different queuing mechanisms, or we could define different metadata for different queuing mechanisms. We think the working group may prefer the first one because the other option will bring difficulty for interoption when we introduce different kind of queuing mechanisms, especially there are a lot of different queuing mechanisms that are being discussed in working group, and there also will potential new mechanisms that will be discussed in IETF. So based on this goal, we try to design the enhanced DETnet data plan encapsulation based on RFC. Oh, I noticed Janos is on the queue. Do you want to ask now or after I finish the presentation?
No, like you seem to be going now into solution, and the previous slide or up to this point was about requirements, and now we have a working group document recently adopted about requirements. So it would be really great to incorporate the requirements and have a consolidated working group document So it would be good if you could discuss with co-authors on the list on how to include the requirement part.
Yes, I think that is a very good question. Actually, this I have also asked in IETF 115 what is the relationship of the requirement of enhanced DETNet and the requirement of large-scale deterministic networking. So, yes, Janos, if we think the working group believe the right method is to combine all these documents, we can try to just work on the only document that has already been adopted. And if working group think we need another document, for example, for the design team that has been mentioned by Liu, I think we are also happy to contribute on a new one. It both work for us.
I think it would be good to have one document for requirements, to be honest, and it's like newer requirements, I would say, for that we can call it scaling, enhanced, and so on. Let's hear what David wants to say in this.
Sure,
David,
sure.
David, go ahead, please.
There we go. Lou, did you want to jump in, or do you want me to go ahead?
Not knowing what you're going to say, sure, I'll jump in. It's really brief. So we have a working group document now that covers enhanced data plane. It's called scaling right now. If anyone has any additional requirements they'd like to see brought into the working group, please just work with the working group, the authors, the mail list. Put your suggestions on list. You have a document here. It's great. Work with the authors and come up with a proposed addition. Discuss it on the list, and once it's agreed to on the list, we can bring it into the working group document. As always, authors have a lot of flexibility on. Authors of working group documents have a lot of flexibility whether they want to incorporate text and then bring it to the working group, or discuss it on the list first and then publish it. There's a lot of flexibility there. So, Shisong, I think you have an open door to bring your requirements into the working group and into the existing working group document.
Okay, sure.
Okay, so I was hoping Lou would say something like that. I'm going to second Lou's remark, which is there is an adopted requirements document for scaling. I would expect the design team to work from a revised version of that document. It is an early version, revision expected. And the other comment I wanted to make is the lower left portion of the slide, we use existing encapsulation field like DSCP. That is something I'd like to see working group discussion on, whether DSCP should be used for DETNet or whether DETNet ought to overlay existing uses of DSCP for other purposes. This really gets into how does DETNet relate to the DiffServ architecture, and that will need to be a working group decision.
And I'd like to jump in here before your response, Shisong. You have another slot where for talking about solution. I think this slot, if we stick to requirements and then move to solution on your second slot, that would be good. And obviously, any type of metadata, any type of mechanisms, those are all about solutions. Thank you.
Yes, actually, we are very willing to combine all these requirement considerations into the existing working group document. Actually, I'm also the co-author of the working group document. The only reason why we raise this topic again as a separated separated presentation is only that do we think the DETNet equals the scaling DETNet? If we think it's the same concept, I think there is no reason to to have another work. If we think there is still some difference, maybe we should discuss how to define the enhanced DETNET and the scaling DETNET. That is my confusion here, actually.
So I think from a chair perspective, let's try to have one requirements document. And if we end up having too much in there or think that it's really two separate discussions, we can separate it out. But right now,
Okay.
At least from my side, and I think as Janos said earlier, from his side, and maybe even from David's side, it seems like these are all overlapping. And so let's put it in one document. And if we need to separate out later, we can do that. Keep in mind, just because it's one requirements document doesn't mean that it's one solution document. I am going to not pronounce the person's name in queue correctly. I apologize for that, but Yishao?
Yeah, thanks, Lu. So as one of the co-authors of the recently adopted requirement document, I would be happy to take this relevant part into discussion and to be included, to be combined into that document. I think that would be as one of the contributor of the working group, I think that would be a great choice. I want to clarify a little bit why it is scaling related at the first point. That's because we are kind of think the scaling, actually the DETNET is already a very good solution right now, but the scaling is, we think, is one of the root cause that we probably need some enhancements to that. So in that case, the data plane is part of the considerations in addition maybe to the control plane. So if the co-authors of this document thinks there could be some other root causes other than the scaling, I think we can have discussion offline and to see whether what's the appropriate text can be included there. Thanks.
Yeah, actually, I think behalf of the co-authors, we are totally fine to combine the contents into the existing working group document. And the reason why we make it separately is because it is suggested by working group to separate this from the solution part. But I think we are on the same page about we will work on the same requirement document first, and to combine this part into the existing scaling DETNET document. And if we are coming out some other points rather than scaling, we can work for other extra document or extra work. I think we are on the same page. It's totally okay for us.
That sounds great. Thank you.
Peng?
Yeah, very quick comments. If we change the large scale to scaling, I think it brings more chance for us to work for more requirements, and it will be open for the future update. Yeah.
Great, thank you. Shusong, is it okay it seems like the rest of this presentation is moving on to solutions. You have another 10 minutes to talk about solutions. Is it all right if we table the discussion here, move on to Torless, and then come back to you? Is that okay?
Sure. Maybe I can give a very quick to go through all the slides, because these slides will not be mentioned in the solution part. It will be very quick, maybe
Okay,
1 minute. Yeah.
You.
Yeah, this page is for how to design the enhanced DETNET data plan. We are trying to introduce the bounded latency information, which could be divided into two types. One is for resource, one is for requirement, which aligns with the definition in RFC 86 and 55. And also, for all these designs for different types of the queuing mechanisms that will be discussed in the following sessions. And this is some proposal which I think also have already been discussed which maybe we need a design team, and we are very happy to see that will happen in the next year, and happy to have David to lead the discussion. We are willing to contribute. Yes, that's all.
Okay, thank you. So this is a little bit of food for thought, given how you know, the past few IETFs we had several really interesting queuing mechanisms that seem to require new data to be carried with packets, and how that is, I think, a great thing that we would want to have, but how do we do it? So next slide. Let me here. Okay, I can do it, right? So I guess, yeah, through the design team, we'll get to the overview comparison and how to move forward with them. But I think what I'm worried about is that we cannot afford separate header for each of the options, right? So we have, for example, in the IPv6 forwarding plane, just, you know, one routing header that we can have. And we would also want to have, of course, pre-auth be combined with the queuing mechanisms. And if every mechanism starts with its own header, then we have a problem with that. So now the process, I guess, the way I predicted is that we can perfectly well define in DETNET the functionality that we want. But when it comes to the encapsulation, packetization of anything we want to have new in the packets, then we'll need to work with and give up control most likely to MPLS, 6-man, or a beer working group if it's for, you know, a multicast. So there are working groups that are doing packet headers for their realm, and that basically means that we also need to explain to them what the packet header needs to do. And so I was starting to reverse engineer from the packet header, thinking as to what we can deliver for that. And so I thought that maybe if we write a draft that is the information model that describes the elements that we want to have in a packet for different mechanisms, without finalizing how they would actually get packetized in the different forwarding plane, MPLS, IPv6, multicast, or so on, then we would have exactly that piece of work that connects what we get out of DETNET from what we need from these other working groups. And so here's a kind of example rundown, which kind of is what I would then try up for next year to write into a draft. And so I was just trying to give a quick rundown of this to give an idea of what we might want to end up in such a document, right? So obviously for the non-latency things, we already know pre-auth. We have a sequence number, we have a flow identifier, we have right now an MPLS header in which it is. Is that good enough? Can we use it in the other forwarding planes? But maybe most easily just at least, you know, re-specify exactly what the attributes are of sequence number and flow ID that we want to have in DETNET packets so that we can perform our pre-auth. Then an example of a queuing mechanism to reduce end-to-end jitter is that we really just have a playout function, right? So that may be another, you know, even draft to write out, but we haven't done this so far. If we use existing queuing mechanisms that are available, we'll have pretty much unbounded jitter, and to reduce that, you could even do that in the last hop router or receiver device by knowing the timestamp when the packet was sent or when it needs to be play out, right? So that's kind of a timestamp information field, and that would be only processed on the last DETNET hop. Then when we go to hop by hop, there are things that we can use, like the experience delay on a per hop basis, and that would basically be updated by every router, and that would allow the receiver to also perform play out buffering, but without having a network-wide clock, right? So that is then different insofar as that it gets updated on every router hop, changed there is something which is novel and would be similar to some other advanced queuing mechanisms. So this is also for a mechanism that hasn't been written as a draft, right? So I was not having the time to get through all the drafts and look at their information elements. But here, obviously, the delay time on a per hop basis, that is what the damper function would require. So there is one damper draft out already. There may be more damper drafts coming. Then obviously for TCQF, which you have heard me talking about repeatedly, that would be a cycle number. Both of these would also be rewritten on every hop. Then priority, to distinguish kind of the latency on a per hop basis, that's been used in a couple of queuing mechanisms. That actually is, I think, the most difficult one if we're getting into this one, because we already need to have some steering header in DETNET if we don't want to do that on a per flow basis. And those steering headers, like in SRMPLS, SRv6, or BRTE, would need to be, able to support such priority element. So there are even been proposals to have per hop deadlines, like in Jakob Stein's proposal, which is currently expired, but which to me would be the hardest one to figure out how to do a packet header for, because it would need a much longer per hop information element that is a deadline, as opposed to priority, which is just 4 bits, which would fit perfectly fine into, let's say, SRv6. So with all these type of information elements, right, it sounds like overwhelming, but I think when we start to think reusing the basic idea of the DSCP, a code point, which is not fixed semantic, but which is a configured semantic, right? We can start thinking about having an information model that says, well, in the packet, we don't really want to have explicit, semantically hard-coded information elements, but we want to have code points that are covering the semantic that is configured on a per class basis, for example. And that concept actually already exists in SRv6, SRH headers. And of course, we are all aware of how this works in DSCP, where you're configuring red, pi, scheduling, queuing parameters for each DSCP to achieve the desired semantic of the DSCP. So here's basically for everybody who is writing one of those queuing drafts, as we call them right now, to think about what's kind of the, maybe shareable set of information elements in packet headers that would be sufficient for you, right? And so I was really thinking, if we get away for the queuing mechanisms with 64 bits, which could be subdivided in 2 times 32 bits, read-writable, and then we would also have only the sequence number and the flow identifier in 32 bits, then that would get us to a point where we have 128 bits for DETNET, and that is as much as an IPv6 address. So that would be well feasible for the amount of overhead that networks are happy or not happy to accept, and might give an idea of how we could converging, right? So that was basically it. This is far out, right? But maybe start to think about what you do in your queuing drafts as information elements, and then maybe we can start thinking about merging them and thinking about how we can have merged encoding for them. Thanks.
Torlis, you have David in queue. Feel free to sort of run the queue during your discussion time. Go ahead, David.
Hi, Carlos. So I like a lot of what I see here, though. I would suggest that you're trying to do 2 things. One of which is incredibly useful now, and the other one of which we're going to be arguing about for a while to come. The one that's really useful now is the taxonomy of all the things that could be carried between nodes, or that taxonomy of trying to divide things up help structure the sort of what are we going to choose to do. I have a feeling that the encoding is going to be a very long discussion, and first of all, figuring out what we really want to carry probably comes before how we go about encoding, and how many bits to spend on what.
Yeah, I completely agree, and I was only giving the encoding stuff, and I wouldn't want to have that encoding unless we really agree that, you know, we have an information model and we define in the taxonomy, you know, these derived information elements, which are code points, or how we want to call them, right, at a later stage. But you're right, I would like to start with the semantic information elements that are required by the different queuing mechanisms, and then be as explicit as knowing, okay, they're read-write in the beginning or on every hop on the receiver, and they need to have the following number of bits for the following size of network. So, and that's painful enough work that I would very much hope that we agree that more of the queuing document authors could help together collecting that information.
Okay, thanks.
Balázs, please go ahead.
Balázs, yeah, sorry, please go ahead, folks.
Balázs, we can't hear you. Shushan?
Actually, I want to provide some consideration about David's question, because as I have mentioned, we are also trying to introduce some metadata for different kind of queuing mechanisms. So that is also a question we have considered. That is why we define two types of boundary latency information. One of them is requirement, one of them is require ID. Because for the requirement, if we consider boundary latency, it will be a timestamp, which limits the how many bits that will be requested. And if it is a resource ID, it can be an integer, depends on the queuing mechanisms. So that's why we do the classification, and we think that will be could be considered if we try to bring or design metadata when we face different kind of queuing mechanisms.
Yezu, please go ahead.
So I think because we have quite a number of queuing mechanisms being proposed here, talking about the metadata, it would be great that if we can kind of identify what are the common parts or so-called fixed fields. What are those? Probably it's already been shown somewhere, but I didn't know. And what are the mechanism, each of the mechanism specific information. So that part would be more like extensible. So the fixed parts and extensible parts for the metadata, there are two types. And also I want to second the opinion that metadata, the formatting is important, but before that, we still need to make sure the group reach some certain level of consensus that the mechanism, I mean the queuing mechanism is to be used for here. Thanks.
Yeah, just quick comment from me. I completely agree. The only thing I always have in the back of my mind is that we do have limits on how much we can carry in packets. The more we want, the more pushback we'll get, and so I keep that in the back of my mind when looking about different proposals that we have. How much would they need in the packet header? How difficult would it be? And I think that's not too unprudent if we keep that in mind.
Balázs, go ahead.
Yeah, thank you. Sorry for my audio issue. As I also added to the chat window, so I think simplification is a very good direction. So I also would like to have a solution where we are limiting the information we are adding to DETNet packets regarding the bounded latency. Whether it is only one or two parameter or just a class information, I think this is up to discussion. but I definitely intend to limit the volume of information we are adding to that net packet. So I think that that's a good direction.
Okay, it seems that we are ready to move on to the next slot. I'll ask you to please respect the time. The last slot on this draft went over quite a bit. So please stick to 10 minutes, including your Q&A time. Thank you. Go ahead.
Hello, can you hear me?
Yes, you sound good, and you should have the controls. So please proceed.
Yeah. This is Li Zhang from Huawei. I will introduce the DETNET enhanced data plan. To meet the goal of minimum and maximum end-to-end latency in data plan, DETNET uses metadata flow ID to identify the DETNET flow, but didn't define the metadata to guarantee the end-to-end latency. Now, there are other requirements of DETNET data plan in draft requirements for large-scale DETNET, including explicit inclusion of the metadata used for traffic treatment capability to different underlying network technologies. To meet the requirement of bounded latency, there have been several mechanisms proposed to DETNET. The list on the left is the existing mechanism, and the right is the drafts. So in this draft, we propose a new DETNET specific metadata called bounded latency information that is carried in data plan used to facilitate DETNET transit node to guarantee the bounded latency. As shown in this figure, bounded latency information is transmitted across multiple DETNET transit nodes and used by DETNET following sublayer. So this page discusses the design principles. Firstly, we think the bounded latency information should be carried in data plan to facilitate DETNET flow to map the forwarding and scheduling resources, not focus on the local mechanisms. Secondly, we think it's good to have a uniform format to accommodate various scheduling mechanisms. Secondly, we classified the mechanism mentioned in the previous page into two categories. One is requirement, which summarizes the requirements from a DETNET service and map to the resource. Another is resource, which indicates the resources. In the BRI data field, we use the BRI type to indicate the type of bounded latency information, and the BRI format is used to indicate the format of bounded latency information. For the field of flag, currently we don't have any definition for it. It is reserved for future study. If there are any mechanism or algorithm accepted by DETNET and the bounded latency information is different with in the table, we will add it. So for the IPv6 based DETNET data plan, we defined a new IPv6 intention header operation called BRI operation. This BRI operation can be encapsulated in either IPv6 hop or hop by hop or DOH extended header depending on the processing behavior. And there may be more than one bounded latency information can appear in one BRI opinion. Similar to IPv6 based DETNET data plan, for the IPRS based data plan, we define a new IPRS extension header called BRI extension header. The processing behavior of IPRS is very similar to IPv6. So the BRI can be also encapsulated in RPRS over UDP or IP-based DETNET data plan. For the use of understanding, we provided some examples to give instruction on how bounded latency information is used in different algorithms, as shown in figure below. This is the comments from IETF-115. For the first comment, we have separated the requirements and the solutions and presented them on this meeting. For the second comment, which querying mechanism is the BRI mapping tool, it depends on the node. For example, the timer resource ID can be represented a cycle ID when cycle queuing mechanism is used on one DETNET node. If there are several queuing mechanisms supported by one node, the marking scheme depends on the node local mechanism. Any comments or suggestions are welcome. Thank you.
Daniel, please go ahead. We don't hear you. Oh.
I'm a little confused. Can you hear me?
Yes, please go ahead.
Yeah. Okay. I'm a little confused about the suggestion from this draft that at the end the delay budget will be encapsulated in the data plane, and I don't understand why it is necessary for the transit load to know exactly what is the end-to-end delay budget, to use it as a parameter to relay and forward to the packet and the flow, because the end-to-end service requirements parameters could be utilized and incorporated into the policies through the control plane. So I do not think it's necessary to put this kind of information as metadata into the data plane of DETNET. Thank you.
Thank you. For the end-to-end delay is used for example, if one node use too much time to forward this package, and the follow next node will try to use little time on forwarding it. That's why we carried the end-to-end delay in the data plan. By cooperate with different nodes in their own forwarding time, they can achieve the end-to-end delay in the required value.
Yeah, I can provide some additional information for Daniel's question. Actually, for the end-to-end delay budget, it is raised by some of the mechanisms that has already been discussed in IEEE, IETF, or some papers. The consideration of how to use end-to-end delay budget in a transit node is open to different type of mechanisms, but the basic idea is that if we have end-to-end delay budget, and when we transit through a packet, transit through a node, the latency that has already been expensed in this node can be minused, and the end-to-end delay budget will be reduced to the left delay budget, and which could be used to direct the packet forwarding in the next node. That is the one possible method to how to use this parameter. The most important thing is that our proposal is now to carry some specified or some particular parameters in the encapsulation. The motivation is similar as Turley's presentation. What we are trying to do is just to find some common metadata that could be used for different mechanisms. And we are also agree about the Bala's suggestion. We should try to simplify the metadata we are trying to carry, and the metadata can be further discussed by working group.
Torlis, if you have something quick, please go ahead, and then you can
just a
continue
quick
on to your
comment. So some of the proposals with the deadlines, I haven't seen, and I don't think even Yakov or so was claiming that there are deterministic latency calculi for them, right? So they're basically based on heuristics, and I think that's another point we need to discuss, whether we want to include them in our mechanisms. It may be useful to share packet headers, but it may not be called deterministic. So that was what came to mind. Okay, let me go on to the slides here. So this was just a quick follow-up, given that the notes from IETF-1415 said we ran out of time and wanted to continue the discussion. I actually didn't want to repeat anything much, except that I felt there was good feedback. And people like the benefits of the TCQF mechanism, and I think the main distinguishing aspect is that it is the only queuing mechanism that gives us a low jitter without the need for new packet headers, because its metadata can fit into the EXP and the IP DSCP. If I'm wrong on that, I'd like to be reminded what competing mechanisms we have that fulfill these requirements of no packet headers. And of course, that is also meant to work for high-speed, large-scale networks, all those good things. I had a great talk with David Black afterwards, so there is some to do for me with respect to trying to generalize the pseudocode that I use as one form of defining how the mechanism works, insofar as that it's too much really doing queuing, NQ and DQ, and he felt, and that's certainly true, that it is more constraining than it needs to be, so that we can have interoperable implementations that use whatever internal mechanisms they want. I actually also just sent an email to the mailing list about, should we call these things queuing as opposed to scheduling? Maybe that's the better term to use, and in the end I'll try to figure out what to do in the pseudocode to achieve that. What I actually wanted to maybe ask for all of us in our documents is, right, what should a queuing document have, right? Because I was trying to figure out what it is, and that's what the TCQF document has. Configuration data model, textual description of per hop processing, and the different ingress and egress processing as necessary, description of the calculus to determine the latency. Of course, if that's a predetermined one, like in our case, I'm pointing to the pre-existing predefined calculus, but it's very simple, of course. The pseudocode then as a more formal method to describe that could, I guess, be in other drafts, be algorithms, math, formulas, and then describing the scalability and performance aspects. And specifically for this document, of course, is right, is do people feel there is anything missing to actually adopt it, right? Given how it doesn't require different packet headers. So what are people missing or not liking about the text? Thanks, David. I'm done.
David?
Waiting for the audio to click on. So Charles, let's see. With respect to use of DSCP, I'm having an immediate reaction on the lines. Just because you can doesn't mean you should. I think it would be better to describe the advantage of this draft as needing a relatively small number of bits that might fit in a DSCP, or the working group might decide that DETNET really ought to be orthogonal to diffserv, and hence we need to find a place to somewhere else to stick that small number of bits. I don't think a decision that says we're going to make DETNET orthogonal to DSCP changes the merits of this draft. I'd like to see the merits characterized in terms of number of bits needed as opposed to where to put them.
Right. Yeah. I think in general I agree, but obviously given how I know how long things take to build into hardware when it comes to different packet headers and the pushback we've been getting with new packet headers in other working groups for other purposes, right? I think in practice there is a relationship to reusing, even if it's considered to be a temporary app use of some existing packet header field.
Yeah, as I said, I would like to separate what needs to be done, and here I fully agree that there is that TCQF gets a lot of leverage out of a relatively small number of bits from an assumption that, oh, we're going to have to put in the DSCP, as I believe, much as you're correct about implementation constraints, that is a fundamental architectural question that I'm sure you'll recall in the first go round for DETNET, the decision was made not to use DSCPs for DETNET. You're asking the decision to be revisited. It should be revisited as an a priori decision, not a consequence of implementation constraints.
Thanks, Xusong.
Agree with David has mentioned. I think DSCP is a good choice, but we should also consider the diffserv meaning of DSCP, whether it is really appropriate to use it in DETNET. I think that is also one point we should consider.
Yeah, I mean, we do have, from the history, some interesting attempts to leverage even within the same flows, different DSCP, like, AF41, AF42 for the guaranteed amount of traffic versus the extraneous amount of traffic for partially congestion controlled traffic flows, right? So this wouldn't be the first time when we logically think it is appropriate to use more than one DSCP for a flow for different purposes. So I don't think I have an architectural reason why it would not be a good idea to use DSCP, but yeah, happy to have that discussion in the design team then.
So, Tola, as you just said, after the discussion in the design team, you are asking what is stands between adoption. I think it's a very good input to the design team of this document, but I guess the design team should discuss and develop the way forward.
Yeah, I said the same thing, but while muted. So thank you. And can we move on to the next presenter, please?
Hello, this is Yizhou. Actually, I think Guangpeng has some emergencies to attend to, so I will be presenting on behalf of him.
Thank you so much. I was wondering where he was and wasn't showing up. So thank you. You should have control of the slides.
Thank you. Let me see it. Okay. Let me see. This is about a variant of CQF and its data plane enhancement. Okay. So I think this has been presented before, so I will try to move quickly for the first few slides. Basically, The first few slides is a brief introduction on the basic or fundamental CQF, which uses two buffers. And if we click on it, the buffers will rotate for each of the cycle. We call the cycle time T or TC in some of the slides. So it click here, then it moves the next hop, then the next hop until going to the sink. So this is a well-known feature, well-known mechanism for the called the fundamental two buffer CQF, and it has a formula here. Let me see. Yeah, this page. So the total queuing time, the minimum should be the number of hops minus 1 times the cycle time plus a dt. Then the maximum is the number of hops plus 1 times the cycle time tc and minus dt. So that time, the dt plays an important role here, because the dt basically is used to absorb all the types of time variance, including the variations in the propagation delay and in the processing delay and other variations like the clock drifting, something like that. So that's the fundamental CQF does. So we are thinking the fundamental CQF has a potential to be widely deployed, because the end-to-end bounded latency can be easily calculated. It's just related to the number of hops and the cycle time. So given the condition that we have more and more link bandwidth, the link speed is higher, so there is potential that the cycle time can be decreased. So it can be decreased from a few hundred milliseconds to a few milliseconds. So that's basically what the left-hand side talks about. In that case, let's try to revisit the dead time. Recall that the dead time is the time required to absorb the time variation. So even with the decreasing of the cycle time, the dead time is still remains there. So basically, the dead time will occupies a large proportion of the cycle time. So that means the dead time will eat up the cycle interval when the cycle time is small. That results in the low link utilization, or sometimes it becomes impractical because the dead time is so large that it basically is 100% or even more of the cycle time. For example, when we take the cycle time to be like a 10 millisecond, then the dead time is normally like a few milliseconds, like 3 or 5, then it becomes impractical. So that gives some requirements of deploy the CQF, the fundamental CQF in large network. So there are 1, 2, 3, 4. There are 4 requirements. We are trying to address the number 3 and number 4 here. Number 3 is the longer links, introducing longer propagation delay. And number 4 is larger processing time variations, because there are large number of nodes, and the node types has great diversity. There are all different types of nodes, so the variations we don't know upfront. So that would be something would be hard for the fundamental CQF, because it requires a shorter cycle time T in order to achieve the lower end-to-end bounding latency. At the same time, it required to maintain a relatively large dead time in order to absorb the time variation, and also to maintain a smaller ratio of dead time over the cycle time in order to achieve better link utilization. There are some existing ways, actually. We call it a CQF variant, that to use more than 2 buffers. So fundamentally, the 3 buffers would work in the rotation manner. That is a quite straightforward way. I'm not going to introduce it in great detail here. It's available in the, I think, in some papers. We don't think the new standard would be required in order to provide how this simple CQF variant would work. So in general, we think it is feasible by increasing the number of buffers. By revisiting, however, when we take a closer look at the CQF variant, there is a time ambiguity window problem. If we look at left side, there are green and red small boxes. So basically, the idea is because there exists the time variation in processing, so the receiving window will swell. So when the cycle time is so small, the receiving window time swells, spanning across more than one cycle. Then that will gives the difficulty in identify which one is the right buffer, right output buffer a particular received packet should be put into. This is because the fundamental CQF use the time demarcation. However, the time demarcation may not work so well because the processing time variations gives it hard to make the right time demarcation unless the DT is so great so that we can clearly separate the swelling receiving window time. So the way out is to make sure that the packet carry the cycle ID metadata so that at the receiving port, it uses that cycle ID to determine which output buffer is the right one to be put. So that's the help to help remove the time ambiguity. So I think this one is some simulation result. If you look at the left-hand side of the picture, we have a flow generator, then two routers, two physical routers. Basically, a flow generator is both the source and both the talker and the sink for the flow. Then the red arrows means the best effort flows as a background, and the green arrows is the high performance or the DETNET flows. So the best effort flows has much larger burst size. Basically, the experiment try to examine actually whether the large burst of the best ever flows will impact the DETNET flows. So the right hand side, it shows that the jitter between the jitter of the DETNET flows using the cycle ID based CQF actually is bounded. So even when the time cycle is so small, is as small as 10 milliseconds. So that's basically show it can work when the cycle time is small. So here is the summary. We are thinking the CQF's attractive features and the potentials for wider deployment. And the CQF variant is straightforward layer 3 extension from the fundamental CQF. By using more than 2 buffers and employ the explicit cycle ID. So the thing is, last time there was a question that IEEE has a project 802.1 QDV, which trying to enhance the CQF. So what we look at it, and also why we still want to we put the CQF variant in the DETNET. This is one of the reason is that we think this the cycle ID based CQF actually is a simple extension, simple CQF variant to the current published standard, which is fundamental CQF 2 buffer or 3 buffer CQF. It does not require the major change of the current CQF like what's being proposed in the ongoing project IEEE 802.1 QDV. So that's the reason why it was put here. I think that's all.
They ran out of time, so I'd like to take your question at the end to leave time for the others, if that's okay.
Yeah, sure.
Okay, thanks. And next, Jinu. Please go
This
ahead.
is Jim. So do I have the control? Okay, I'll just proceed. Okay. Yeah, the title is Asynchronous Deterministic Networking. With the ADN, we try to avoid slot operations and strict time synchronizations. Oh, I do have the control. Yeah, here the framework tries to focus on decoupling the latency guarantee problem from the jitter guarantee problem. First, we can guarantee the latency on end-to-end basis, not per hop. Since the E2E latency, end-to-end latency bound of a packet could be less than the sum of the bounds per hop. Here, the two solutions are introduced, regulators and the metadata-based forwarding. The metadata could be the so-called global finish time. It will be introduced in the next slides. And the jitter guarantee. The jitter guarantee solution can utilize the already latency guaranteed network and time stamping function and buffering. Okay, so the latency guarantee solutions. The first one is the ATS. It is very well known. All of us is very well aware, I guess. So I will just briefly introduce. It is composed of the two part FIFO system and IR. The key here is that the interleaved regulator does not increase the maximum latency of a FIFO system. The FIFO system usually is a combination of an output queue and scheduler and switching fabric up until an input port module. So it encompasses just one hop. And the next solution I would like to introduce is the FAIR, which is the flow aggregate and IR. It's a combination of flow aggregation and the interleaved regulators in between. So here the whole network is divided into several aggregation domain we call AD. And only at the boundary of the AD, the IRs are placed. The IRs are operate per flow aggregate. And in a sense, it is a generalized ATS. As you can see in the table in the bottom left, the FAIR framework even encompasses the int_serve, which doesn't have a regulator, but the scheduler is based on the flows. The queues are assigned per flow, and the queues are served accordingly. But maintaining queues per flow is too complex, so we do not accept inter-service as our solutions. So here, FAIR is a compromise in between. It can have complexity of the ATS, but can be performed even better than the inter-serve. As you can see in this analysis, this analysis is too complex, so I will just briefly go over. So the basic idea is that the network is very large, they are divided into several parts called the AD. And the topology and the flows are all completely symmetrical. And the flows are all identical. In that case, if we divide the network into proper ADs, you can have the FAIR can show the best performance in terms of the latency bound, end-to-end latency bound. So the ATS, the interserve, and the FAIR, that's the order of the value of the latency bound. And as the last solution with the regulator, it is introduced the port-based flow aggregate regulation. It can be placed at every node or at critical links to break the cycle. So the cycle in the topology plays a very bad role that accumulates the burst and feed for the burst accumulation, and it can break the stability of the network. So breaking the cycle is very important. So in that regard, the port-based FA regulation is focused on that respect. So here the key is that regulate the flow aggregate itself, not individual flow. If you remember, the IR maintains only one queue per flow aggregate, but its regulation is per flow. So it has to maintain the flow states. But here, forget about the flows, forget all the individual flows, just maintain the flow aggregate parameters. That is the sum of the bursts of all the flows and sum of the average rates of all the flows. So it has the best scalability. But it turns out that it works quite good. So here, another topology. It is also symmetrical, but has only 9 nodes. The flows are, yeah, you can take a look how the flows around. And here in a single arrow or single line, there are many microflows. So the single line, for example, the red arrow line, is a flow aggregate actually, which has number n microflows inside. So by increasing the n, we can control the utilization. So in the graph on the right, you can see the end-to-end latency bound as the function of the utilization. Here, ATS IR performs best, but the port-based flow aggregate regulation also works fine. Yeah, and the latency guarantee framework with the global finish time. So the theory is very complicated, so I will skip all of them because I already introduced them in the 1-on-5 meeting. The key here is that to carry the metadata, two metadata. One is the global finish time, and then DHP. This is very hard to name, but it is related with the delay experienced by packet P in node H. These two metadata can be kept, and having these metadata inside and use them as global finish time, we can have very good performance. So here, virtual clock is the reference. It is a very old classic scheduler, but it is very complex in the sense that it has to keep the flow states in every node. But here, the proposed solution does not carry the flow state inside does not maintain the flow state in core nodes. It maintains only at the source node, and it carries as the metadata. And using that metadata, the scheduling is performed. So here, the flow is protected. Yeah, up until here, we have seen the solution for the latency guarantee. And we can also guarantee the jitter using the timestamping metadata. It has a very good feature that the end-to-end buffer latency is bounded. Yeah, okay. Thank you. Oh, just one more page, sorry. So we have experimented with the embedded system, and even with the clock drift between two physical embedded nodes, which is 6 microseconds per second, using a clock drift compensation algorithm, we could maintain that the overall jitter is bounded by 10 microsecond. Thank you. That's it.
Okay, thank you very much. We'll move over to Xiaofu. Please proceed. We don't hear you. Your mic looks like you're still muted. Xiaofu, please try to unmute. Very low.
Hello? Can you hear me?
Yes, we hear you.
Okay.
Thank you.
Oh, sorry, I'm sorry. Okay. I'm Sofupen from GT, and I will present the deadline-based forwarding scheme. I go to the next page. So the screen is not shared. Sorry.
We see your second slide. It says motivations. If you'd like, we can drive.
Yeah. Yeah, I clicked the second, but it has not any effect.
We see the slides changing.
Okay. Yeah, okay, sorry. There's some more delay. So the proposal is to find a potential queue mechanism suitable for large-scale networks to provide deterministic queues. As we know, there are many existing scheduling algorithms such as CBS, ATS, strict priority, and EDF. But they cannot be directly used in IP network to achieve deterministic queues. So this proposal is to discuss a variant of EDF with enhanced latency compensation. The three key attributes of the deadline queue. The first one is the countdown time, which indicates the countdown waiting for scheduling. And the second is the rotation time interval, which indicates the decreasing step of countdown time. And the third one is authorization time, which indicates the continuous sending duration when the queue is scheduled. And there are two scheduling modes and types of queue, that is in time and on time. The main deadline information of the packet is the planned residence time and the residence time valuation. We can calculate the allowable queuing delay based on the planned residence time. the resistance time evaluation and the forwarding delay inside the node. Then map the packet to the queue with appropriate countdown time range. So these are example below. I'm not described in detail. The operators can take a specific planned resistance time as a specific class. Firstly, we can get the schedulability condition for in-timer mode. If each class has a preset traffic constraint function, for example, the leaky bucket, then we can suggest a planned resistance time value for each class, or vice versa. Then for untimer mode, we suggest a loose untimer scheduling to also meet the schedulability condition and take a strict untimer scheduling and egress node. We think that the receiving an intermediate node is not necessary for the scheme. For an individual service, it can allocate the bandwidth from the traffic constraint function of a specific class, as just mentioned. And at the ingress node, take admission controller an incoming port and take orchestrating and output port according to the allocated bandwidth. So there's another example I was not described in detail. So this is a partially upgraded scenarios. In some cases, if the traditional strict priority network, for example, with few hops, which can provide a bounded delay, then it can only upgrade the support of the and several board nodes to control the delay jitter of traffic. We hope that the board nodes can get the information of the packets. For example, the legacy device may merge and insert the information into packets, even don't support the based scheduling, or there may be other means. For deployed considerations, a small planned resistance time is used for low latency requirement. We don't suggest a large planned resistance time for untimed service. We can take a loose untimed scheduling and transit nodes, and take a strict untimed scheduling and egress node. So this page is for encapsulations. Is the information carried in the IPv6 package, which is the extension of hop by hop option. As mentioned before, the main data information is the planned resistance time and the resistance time valuation, and the scheduling mode is in time and untime. So this page is about the evaluation of whether this proposal is suitable to IP networks. Later, we will further evaluate the adaptability of this proposal to the large-scale network deterministic requirements document. For the four aspects, I will not describe it in detail. So thank you. We welcome to any comments and cooperation.
Please go ahead.
So I have a couple of questions. The first is, could you go back? I think go back 2 slides, if, please. You need to. Sorry, 3 slides. Deployment considerations, please.
Several considerations.
Yeah, this one.
Yeah.
I'm trying to understand the suggestion. Are you suggesting that that there be two DetNet services, one of which is effectively bounded latency, and which you've referred to as in time, and the other being the strict on time service that essentially delivers at the precise deadline?
Yes.
Yeah, I'm trying to understand how it interacts with the DetNet architecture, which to date has been focused solely on bounded latency. We can just leave it as a question to follow up on later. And the other question I have is if we can go forward to go to the evaluation, 2 slides forward. I don't understand the comment on deployment considerations about one slide. I do not understand the first comment under cost. The time synchronization is not required between network nodes. Surely you're assuming some form of global time base given your use of absolute deadline times. So what exactly is the assumption on time synchronization?
For deadline-based scheme, we don't rely on the time synchronization because our mechanism is based on an offset of time. That is a local time. Maybe we can discuss in main list.
Okay, maybe we can discuss on the mailing list because something there's something that's not making sense about this picture.
Okay, we can make a clarification on main list. Thank you.
And with that, we're going to move to the last slot, the last presentation. Kwan? Please go ahead. Yeah, we hear you. Thank you.
Thank you. This is Chuan from ZT. My presentation is the queuing-based enhancement. Okay. Let's first do the recap of the queuing-based enhancement. First, from September in 2021, the working group agreed to discuss the queuing-based topics. And then in IETF 112 and 113, we continue to discuss the queuing-based requirements, and now it's the scaling that led. And then in April and June 2022, we submitted the queuing-based data plane solution for IPv6 and MPLC encapsulation. And then in July 2022, the working group realized the new charter and the milestone for the enhanced LET. So we updated the drafts to align with the terminology of the requirement. And then we discussed the gap analysis and the enhancement of the data plane framework at IETF 115. So this meeting, we plan to discuss the queuing-based enhancement for the scaling DETNET. So first, we just want to present the gap analysis. As mentioned just now, the primary goals for DETNET queues is to support the different levels of the DETNET queues for multiple services. So we must first discuss the characteristics of the scaling deterministic networks. We just defined that into two parts. One is the large-scale dynamic flows with requirements for different levels of different queues, and the other one is large-scale network topology, including large number of nodes and links. So we try to summarize the gap list, including the functions, to provide the aggregated flows and application in surface sublayer and deterministic latency in forwarding sublayer. For the aggregated flows, it requires large amount controlling signaling to establish and maintain DETNET data plane, DETNET per flows or aggregate flows. For deterministic latency, it may lead to support the enhancement of queuing mechanisms, including the metadata, is the focused on this meeting. So what's the queuing based enhancement? We just provide the queuing based enhanced functions and metadata. We propose that the packet treatment should indicate the behavioral action, ensuring the deterministic latency at the DETNET loads, including the queuing mechanisms and the related metadata. And first of all, it is necessary to list all queuing mechanisms out and discuss which queuing mechanisms expects to carry queuing information as metadata. For some queuing mechanisms, the queuing-based information should be carried in metadata for the correlations between nodes, and some other queuing mechanisms don't need to carry the metadata. For example, the cycle and the deadline information should be carried in the metadata. And for the it is supposed that the resources over the data plane should adapt to the different demands of the data service. So the format of the data plane enhancement must be generic, and the format must be applied to all the queuing mechanisms. So the data plane encapsulation needs to be simplified, as just mentioned, and for the implementation consideration. And so we propose the necessary information is expected to be carried. And the other information could be configured on the control plane. So we proposed the IPv6 extension solution to provide the encapsulation for the information of the data flows to achieve the end-to-end deterministic latency. We also agreed to define the format into two parts, the fixed part and the flexible part. The fixed part is need to be generic and be applicable to all queuing mechanisms. But the queuing information metadata is specific for each queuing mechanism. So this part is flexible and in variable length. So we define the new option for the net to signal the deterministic latency. We defined the deterministic latency action type to indicate the actions. We defined the type, the action into two types. The first type is that indicates the behavioral action type over packet treatment. It is related to different service requirement. And an alternative option may be reusing the DSCP field. and the subtype indicates the type of functions ensuring the deterministic latency, including the queuing mechanism and the related metadata. So it is the same with the MPL's MPL's encapsulation. We also propose the MPL's extension solution for the queuing-based metadata. But these extensions are aligned with the ongoing work in MPL's working group. For example, the SP label SPL is added to indicate the deterministic latency action DLA. The SPL to indicate the presence of the MPL's network action and the MPL's DLA substack. So finally, we have discussed some solutions for the queuing-based enhancement. I think it is first necessary to list all queuing mechanisms out in DETNET and discuss which queuing mechanisms expect to carry queuing information as metadata, and then to design the common format for the queuing information. So that should first get a confirmation from a working group first, which queuing mechanisms should be enhanced in DETNET. And then we will follow the charter and milestone of the DETNET and align with the terminology. So comments and the questions are appreciated. Thank you.
Okay, thank you. I'd like to open the floor for any comments. I'll point out we don't have a lot of time for discussion, but we do expect that the discussion will be centered in the design team. Our expectation is also when the design team is formed that all design team meetings will be open for even those who are not on the design team to come and participate.
Yes. Okay.
Yeah, just two quick comments. So one was Gino's great slides on derived from ATS. I think the one issue about scalability, unless I misunderstood it, is what I had in my first slide about CQF, that I still have to have with 100 ingress and egress nodes, 100 times 110,000 flows that I need to carry in these type of mechanisms, unless I have something that allows me to aggregate on midpoint hops, which the CQF solutions, for example, do. And the second point was something that I think is applicable to all the queuing things. We need to figure out how much we think it is feasible to have that per hop per flow steering state on the 5 or 6 tuple of DETNET flows still there when we do need to have the queuing be better scalable, right? Because the per hop per flow steering state may also be an issue, and I think that is not at the core of the queuing mechanisms, but it's kind of a question for the scalability. So I think, on behalf of the co-authors, hopefully we can get more input on what the working group feels about that.
Do I suppose to answer now, or? Oh, just quick answer then. Yes, you are correct. The scalability on ATS, we still have to carry we have to maintain the flow stage of the flow individually. Yes, so that's the main drawback of ATS. So the FAIR and PFAR is the mitigation, I would say, especially the PFAR, the per foot flow aggregate regulator doesn't have that issue. And the last solution, C score, I would name it. It is even simpler. It is more scalable. The detail I could elaborate maybe in the email or yeah. Thank you.
Mail until we have the design team when we hopefully have more time for discussion. Thanks.
So there are some similarities in some of the drafts. There's no reason why authors can't get together and start talking inside author groups while we're waiting for the design team. So don't wait. Please feel free to meet informally. Feel free to use the mailing list. If you'd like to use IETF resources, working group resources, contact the chair's alias, and we'll set them up. And you can have informal meetings between now and the formal start of the design team. With that, we are pretty much out of time. I'd like to thank everyone for participating. Clearly a lot of energy in this topic, which is what you would always like to see in a contribution-driven organization. So that's really great. János, do you want to add anything?
I would like to just thank everyone also. Very good discussion. And let's continue. And happy holidays, I guess.
Absolutely, absolutely. Well, thank you all, and look forward to seeing you virtually and eventually physically, hopefully in one of the upcoming meetings. Thank you all.
Thank you. Bye-bye.
Thank you. Bye.